Right. Yeah, I'm not as happy on the green because it is basically using that turbocharger aneroid, but they will always have a mixture control lever. That's your best answer. Right, a positive displacement, meaning that when it makes one revolution, displacement. Remember we talk engine displacement? How many cubic inches of air does the piston displace when it goes up and down? Um, our engines are not they're basically an air pump, but they are not a positive displacement air pump because we've got all this stuff going on with valve overlap, and especially because what we pump is um, uh, is a gas, and you can get more or less gas. We don't get, we don't. It's not a fixed amount. When we're pumping a liquid through a positive displacement pump, like I said, if you put one revolution, it's going to turn. At one revolution, it's going to pump 1 cubic centimeter of liquid, and it'll break or pump that much fluid. Oops, that's not what I meant to do. I meant to hit this one. Right off the engine. Yes. Variable speed drive from the engine. Okay, so that one's confused a few people. Maybe you're thinking that it speeds up and slows down. There is a unit, a type of drive called a variable speed drive. What that means is you can change the gear ratio. So sometimes the engine moves, one revolution and the pump does one, and sometimes the engine moves one revolution and the pump does two, like a multi-speed. It is a direct drive off the engine. You took it off your engine. Remember, there's a gear off the back of your fuel pump, directly driven off. I think it's the camshaft gear, and nothing changes. The direct drive. Nice. Airflow is not measured. There's no venturi. Good. Lower pressure. It's the same pressure. Very similar. Yeah, altitude not so much. Turbocharger boost pressure. Yes, and engine RPM. Engine RPM being the best one. Haven't talked about the electric boost pump much. There's a picture of one though. How much control does it look like it's got? Not much. 2 wires. You can turn it off. You can turn it on. And you can turn it back off again. And you can turn it back on again. Nope. They're just 28 volts. There are some I've heard of that have got a selector. You can do low boost and high boost, but I have not seen one like that. I remember hearing somewhere that they exist somewhere. So it's just going to put out whatever pressure it's designed to put out, and they function a little bit differently, and they do their best to always make 25 psi or something. So I suppose the throttle position might kind of affect the whole system, but for the purpose of understanding the theory, you turn it on and it makes its pressure. Students do surprisingly bad on this. I thought this was like the easiest of my silly questions. And then I saw the results and thought, my gosh. You guys did pretty well. Pretty good. All right, could be. The question said, what part moves only diagonally? Boost pump pressure. Right, spring pressure. What does this spring do? Does it open it or close it? The spring opens it. There's the valve plate right there. Let me pull this up. Obviously, that couldn't get understood well. Where's my... Here's my bypass valve. Down here, spring is pushing this way on this little plate. When that plate is moved to the left, the valve is closed and the spring is pushing it closed. If I've got a boost pump forcing fuel down this thing's throat, it will push past there. Wastegate. Oh, that's turbocharger. Oh, I see. Because I said in turbocharged. And you're thinking the wastegate bypass. Ah, I see where the confusion came from. I was talking about the bypass valve in the fuel pump. Let's go back to my Kahoot. Spring open, oil close. Yes. But the bypass valve in the fuel pump is spring close, fuel open. Well, or fuel close. Depends on where the fuel comes from. So I see why. Fuel pump bypass valve. Right. Right. Spring pressure and then the engine-driven pump pressure will also help. you want to get creative. Rich mixture during acceleration. Well, at least everybody was picking the mixture thing. Remember, we would end up with the turbo lag means I don't get enough air. And if I deliver all of my fuel and not enough air, it will be too rich. Opposite problem from carburetors and other systems. But without the turbo boost all the way there, you'd get all of the fuel and not all of the oxygen. That's too rich. Engine's going to really hesitate and struggle with that. Bypass line plumbed to the fuel control. Well, at least people got bypass. This bypass valve right here is built right into the pump. That's why the correct answer is bypass valve in the engine-driven fuel pump. It's right inside the pump. This whole, it's right inside this housing. TCM, Teledyne Continental Motors. Nice. Most people got it. Fuel control lever in the cockpit. You're thinking mixture control, and that's the other valve. There we go. Control lever in the cockpit. Red handle. This one's pretty easy. Seriously, this one's really easy. Like, this is the kind of question that students really want on the tests. See? This one's really easy. Like, all you needed to do was pick something. Nice. And no, that question will not be on the test written like that. I don't think I'd pass the Transport Canada audit if I did that. Oh, I didn't talk about this one much. Fuel return valve. There's an orifice Overpressure relief valve. That's our low pressure. That's not an overpressure relief valve. Shear shaft. Most of you, some of them are missing, but most of you should have had a shear shaft drive for your fuel pump. And I'll just draw one of these things for you. Yeah, this will work. Your shear shaft looks to be kind of a blown up view of it. And these parts here were square. And this part here is round. And this whole thing is about, I've blown this out, this whole thing was about 1 inch from there to there. And the point of this is if, let's see if I can draw this a bit better. If your vane pump, your pump is going to be on this side, and your engine, and this whole thing was built inside of this is built inside the gear. This slid into the slot there. If your vane pump breaks or jams or whatever, this will break right here and allow the engine to continue to turn even though the pump has ceased. You'll find that in various places in mechanical devices. They'll build a weak link. So don't worry too much about that one, but good to know. Cruise power. It's what we call our high unmetered fuel pressure. How do we adjust the high unmetered fuel pressure or cruise RPM? I haven't given it the same name. Relief valve screw. Okay. I deliberately gave it a little bit of a different name in here to see what you're understanding. The relief valve screw does not adjust cruise power. Cruise power is the variable orifice, and that is the return orifice. And my fuel is returning within the pump. I named it differently. I won't do that on the actual test, but I'm hoping you understand that this return orifice is what this variable orifice is a return path for the fuel. So sorry if I confused you on the Kahoot, but this is something you're going to want to know tomorrow. Yes, it does. The throttle plate position is directly linked to the fuel metering valve. So when the throttle plate is wide open, this valve will be wide open, and that is a controlling input into this system. In the Bendix system, in a carburetor, there's no such thing. Well, I shouldn't say that. There is in the Bendix. There is not in the carburetor. In the Bendix, there is, but it's not got nearly as much authority. All right, we're done here. Who wants to do the first presentation? Travis, who's in your group? Travis? Travis, Evan, and Sean. Okay, Isaac wants to go second. Who's third? Yato. All right. Isaac